Hello. Today I'll be explaining the concept of resistance in electrical circuits. By the end of this presentation, you'll understand what resistance is, its impact on circuits, and how it relates to Ohm's law. Resistance is essentially the opposition to electric current, and it's measured in ohms. Think of how easily current can flow through a material. For example, materials like copper allow more current to pass through because they have low resistance, while materials like rubber reduce current flow because they have high resistance. There are several factors that can influence resistance. The material of the conductor matters. Metals like copper have low resistance, while rubber, for example, has high resistance. Length also plays a role. The longer the conductor, the more resistance it offers because the electrons travel a greater distance. Similarly, cross-sectional area impacts resistance. Thicker wires offer less resistance as they provide more pathways for the current to flow. Lastly, temperature increases resistance because it causes atoms to vibrate more, hindering the movement of electrons. Now, let's dive into Ohm's law, which relates voltage, current, and resistance in a circuit. The formula is I equals V over R, where I is current, V is voltage, and R is resistance. Ohm's law shows that as voltage increases or resistance decreases, the current flowing through the circuit will increase. This is crucial for designing circuits and ensuring devices can work efficiently and safely. Here's an example to help you understand better. If you have a 9-volt battery and a 3 ohm resistor in a circuit, you can calculate the current using Ohm's law, I equals V over R. In this example, I equals 9 volts over 3 ohms, which equals 3 amps. This shows how voltage, resistance, and current are all interconnected in a circuit. In conclusion, resistance controls the flow of current in electrical circuits and is influenced by factors like material, length, temperature, and cross-sectional area. Ohm's law helps us calculate current and resistance, ensuring our electrical devices work efficiently. Resistance is important in everyday devices like light bulbs, heaters, and power lines. Understanding it helps us design safer and more effective electrical systems. Thank you.